In this video, we're gonna try to show that the following statement is false. We wanna prove that if f and g are differentiable functions and f of x is bigger or equal than g of x for x in a, b, or x between a and b, then f prime of x is greater or equal than g prime of x for x between a and b. Okay, the statement means that if we have two functions, let's say this is a, b, and let's say this is some f, okay, and this is f of x here, and this is g of x. Okay, I have drawn them is like shifted now. Let's say let's make f like this, g like this. Okay, so here f of x is bigger than g of x because it's on top of it. Okay, but the issue that we have is that if we find f prime of x and g prime of x, okay, we don't have f prime of x is still bigger than g prime of x. Okay, and in our case here, the easiest way to prove that such a statement is false is we can find some examples. Okay, and I think I have answered this question before. I'm not sure where I put it, but so this is just a clarification of the issue. Okay, so the easiest way I can do is that I can define two functions on this interval 0, 1. In this case, a is 0 and b is 1. Okay, and my x is gonna be between this one, 0 and 1. We don't include the boundaries because sometimes crazy things might happen in the boundaries. Okay, and in my example here, I want to find two functions f and g that would satisfy this one here, these two conditions. So f and g differentiable. If I take f of x as 1 and g of x as x, and I define both of them on this interval 0, 1. Okay, so here this is my f of x, and this is my g. Okay, this is g of x. I clearly see that f of x is bigger than g of x graphically. Okay, or you can see that if x is between 0 and 1, then x is less than 1. Okay, and here I have both of them are differentiable because this is a constant, it's differentiable, and this is differentiable and it's equal to 1. Okay, we know how to find the derivative, and f and g is differentiable in this case. Okay, now let's move to this statement here. Yeah, so f prime is 1 and f prime is 0. So here, because f of x is 1, so f prime of x is 0. Okay, and g of x is just 1, so I have 0 bigger than 1. Okay, so that means that this statement is false. So I have used simple, very basic and simple functions, okay, to show that this one is that this statement is false. Okay. Okay, so it's not something that we know about integrals. We know that if f of x is less than g of x, if x is in this interval ab, then we know that the integral of f of x dx between a and b is less than the integral of g of x dx between a and b. So here, for the integral is nice. Most of the time we have these properties, but differentiation is different. Okay, so and these examples, these two shows that at least for the differentiability, we don't have this order preservation. Okay, we don't preserve the order. So here we have f is bigger than g, but f prime can be less than g prime. Okay, so the key is that this result is false, and when we try to prove it, we just find some easy example like this one here and this simple interval 0, 1. Okay, so this proves that this statement is false. Okay, I didn't edit the video, and if you see any errors or mistakes, please let me know. Thank you very much. Please like, share, and subscribe. Thank you again.